What if one physical network switch could behave like several completely independent switches? Imagine having different customers, applications, or departments connected to the same physical infrastructure, but their traffic remains completely separated. They cannot see each other. They can even use the same IP addresses without creating any conflict. This is possible through switch virtualization technologies such as VRF, VDC, and multi-tenancy. In this episode, we'll understand what these technologies are, how they are different, and where they are used in real data centers. Let's get started. Modern data centers support many different customers, applications, teams, and services, but building a completely separate physical network for every customer would be expensive and difficult to manage. Imagine purchasing a new switch every time a new customer or department needs its own network. You would need more rack space, more power, more cooling, more cables, and more management. Instead, network engineers can virtualize the physical switch. This means one physical device can provide multiple logical networking environments. Each environment can be used by a different customer, department, or application. For example, tenant A, tenant B, tenant C, and tenant D can all share the same physical switch. However, their traffic and configurations remain separated. The main reasons for using switch virtualization are network isolation, better security, lower hardware costs, and simpler management. It is similar to server virtualization. With server virtualization, one physical server can run multiple virtual machines. With switch virtualization, one physical network device can support multiple logical networking environments. VRF stands for Virtual Routing and Forwarding. Normally, a layer 3 switch or router uses one global routing table. That routing table contains all the routes the device knows and helps the device decide where to forward traffic. With VRF, the same physical device can maintain multiple independent routing tables. For example, VRF blue can belong to customer A, while VRF green belongs to customer B. Each VRF has its own routes, interfaces, and forwarding decisions. The routes inside VRF blue are not automatically visible inside VRF green. This creates logical separation between the two networks. One of the most useful features of VRF is the ability to reuse the same IP addresses. Customer A may use the address 10.0.0.1 inside VRF blue. Customer B can also use 10.0.0.1 inside VRF green. There is no conflict because the addresses belong to separate routing tables. You can think of each VRF as a separate virtual router running inside the same physical device. VRF is mainly used to create secure and isolated routing domains. The first major benefit is network isolation. Different customers, departments, or applications can use the same physical infrastructure without sharing the same routing table. The second benefit is improved security. Because the routing tables are separated, traffic cannot automatically move from one VRF to another. Communication between VRFs must be intentionally configured through techniques such as route leaking, firewalls, or shared service networks. The third benefit is support for overlapping IP addresses. Different customers can use the same private IP range such as 192.168.1.0/24. Because each network exists in a different VRF, there is no routing conflict. VRF also makes multi-tenant operations easier. A service provider can support many customers on the same infrastructure while keeping their networks logically separated. VRFs are widely used in enterprise data centers, service provider networks, MPLS, VPNs, Cisco ACI environments, and cloud networking. The key idea is simple: same infrastructure, separate routing tables, and isolated traffic. VDC stands for Virtual Device Context. A VDC divides one physical Cisco Nexus switch into multiple logical switches. VDC technology is mainly associated with modular Cisco Nexus platforms, especially the Nexus 7000 series. Each VDC behaves almost like a separate physical device. For example, one physical Nexus switch could contain VDC1 for the marketing network, VDC2 for the sales network, and VDC3 for guest services. Each VDC can have its own configuration. Physical interfaces can be assigned to specific VDCs. Each VDC can also have its own VLANs, routing protocols, administrative access, and management responsibilities. An administrator responsible for VDC1 may not have access to the configuration of VDC2. This provides a stronger separation than simply creating multiple routing tables. From an operational point of view, each VDC looks and behaves like an independent switch. However, all the VDCs still share the same physical chassis. This allows large organizations to reduce the number of physical devices while maintaining separate administrative and network environments. VRF and VDC are both virtualization technologies, but they operate at different levels. VRF virtualizes the routing function. It creates multiple independent routing tables inside the same router or layer 3 switch. The physical device still has one main configuration and management structure. VDC, on the other hand, virtualizes the complete switch. Each VDC can have its own interfaces, configuration, VLANs, routing protocols, and administrators. Here's a simple analogy. Think of VRFs as apartments inside one building. Each apartment is separated and private, but all apartments are still part of the same building. VDCs are more like separate buildings located on the same piece of land. They share the underlying physical location, but each building operates independently. Another way to remember the difference is this: VRF creates multiple virtual routers. VDC creates multiple virtual switches. VRF is commonly used for traffic and routing separation. VDC is used when stronger device level and administrative separation is required. Multi-tenancy means allowing multiple customers, departments, or applications to share the same physical infrastructure while remaining logically isolated. Each customer or organization is called a tenant. For example, tenant A, tenant B, and tenant C can all use the same physical Nexus switch. Each tenant may have its own web servers, application servers, databases, routing policies, and security rules. Tenant A could use VRF Blue, tenant B could use VRF Green, tenant C could use VRF Purple. Even though all three tenants share the same physical hardware, their traffic remains separate. One major benefit of multi-tenancy is better resource utilization. Instead of dedicating separate hardware to every customer, the infrastructure can be shared more efficiently. This also reduces hardware, power, cooling, and operational costs. Multi-tenancy also makes scaling easier. When a new tenant is added, engineers do not always need to install new physical devices. They can create a new logical environment on the existing infrastructure. However, proper isolation is extremely important. Each tenant must have independent policies, routing, and security controls. Let's look at a practical example. Tenant A and Tenant B are connected to the same physical Nexus switch. Both tenants use the network 192.168.1.0/24. Normally, using the same IP range on the same routing device would create a conflict, but Tenant A belongs to VRF Blue, while Tenant B belongs to VRF Green. VRF Blue has its own routing table. VRF Green has a completely separate routing table. Inside VRF Blue, the network 192.168.1.0/24 belongs to Tenant A. Inside VRF Green, the same network belongs to Tenant B. Because the two routing tables are independent, the switch treats them as separate networks. Tenant A cannot see Tenant B. Tenant B cannot directly access Tenant A. There is no IP conflict and no accidental routing between the tenants. Security policies can also be applied separately to each tenant. This is very useful for cloud providers, colocation facilities, service providers, and large enterprises. The result is one physical infrastructure supporting multiple isolation networks. VRF, VDC, and multi-tenancy are used in many different environments. In enterprise data centers, VRFs can separate departments such as finance, human resource, production, development, and guest services. Service providers use VRFs to separate customer network and deliver services such as MPLS Layer 3 VPNs. Cisco Nexus 7000 switches can use VDCs to create multiple logical switches inside one physical chassis. Cisco ACI uses tenants, VRFs, bridge domains, endpoint groups, and contracts to create policy-based multi-tenant environments. VMware NSX provides similar ideas through software-defined logical switching and routing. Public cloud providers such as AWS, Microsoft Azure, and Google Cloud also use large-scale multi-tenancy. Thousands of customers share the same cloud infrastructure while their virtual networks remain isolated. Financial organizations and government networks use segmentation to meet strict security and compliance requirements. Colocation and hosting providers also use these technologies to support many customers efficiently. Although the implementation may be different across platforms, the main objectives remain the same: isolation, security, scalability, and efficient use of shared infrastructure. Let's bring everything together. VRF creates multi-independent routing tables. It is mainly used to separate traffic and routing domains. VDC divides one physical switch into multiple logical switches. Each VDC can have independent interfaces, configurations, routing protocols, and administrators. Multi-tenancy allows multiple customers or applications to share the same infrastructure while remaining isolated. These technologies can also be combined. A physical Nexus switch may contain multiple VDCs. Inside each VDC, engineers may create multiple VRFs. Each VRF may then support a different tenant or application environment. This creates multiple layers of separation. The physical infrastructure is shared, but the tenants remain logically independent. The main benefits are better segmentation, stronger security, improved hardware utilization, lower costs, and easier scalability. The most important thing is to design the separations correctly. Virtualization provides flexibility, but engineers must still plan routing, security policies, resource allocation, management access, and failure domain carefully. Now you understand the big picture of switch virtualization. VRF separates routing tables. VDC separates the switch into logical devices. Multi-tenancy allows different customers or applications to safely share the same infrastructure. Together, these technologies help modern data centers become more scalable, flexible, secure, and cost-efficient. In the next episode of Data Center Fundamentals, we'll move into Nexus Routing Basics. We'll discuss static routing and introduce routing protocols such as OSPF, EIGRP, and BGP on Cisco Nexus switches. Subscribe to Next Layer Tech and enables notifications so you don't miss the next episode. Thanks for watching, and I'll see you in the next video.